And they're taking their quiz in the first 10 minutes. I'll have your quiz posted sometime tonight. So when I send you the link, it'll be on the tab on Microsoft Teams that says quiz and test. That's where you'll find it. If you can't find it, send me an email. We'll help you through. So we're going to be doing nothing here until they're finished their quiz. So if you want to take a break, About a minute. All right. Then we're going to go over the test. Literally, Jack took forever to finish his test, so we finally finished it yesterday. Oh, I got a stamp. What's your stamp say? Perfect. So Allie is the queen of geometry until she's dethroned. All right, very good, Allie.
That's not. Wait, what? How did that's not wrong though?
Both you and Anna missed the same question.
But that's not wrong. Number 17.
So it doesn't say a point or a plane. It says a point or a line. It says a point and a line. So if you have a point and a line, there's only one plane that touches both.
It says a line that's not, a point that's not on the line.
Yeah, you said if you have a line and a point that's not on that line, lie in more than one plane is what it says.
So it's false.
So it's false. So I got it right.
You didn't put that.
I didn't put false.
No, read it again.
Read
it again. Read it slowly.
A line and a point not on that line lie in more than one plane.
What does more than one mean?
A lot.
So you're saying a line and a point not on that line lie in more than two planes?
No.
They land one, exactly one.
Yeah.
So that's false.
Exactly. That's why I put false.
Hold on.
That's why I put
Now
false.
you're confusing me. A line and a point not on a line lie in more than one plane. That's, uh-oh. Did I just mark this wrong? No. All right, you got perfect paper. Good job. Did I mark yours wrong? No. Okay. Sorry. Sorry. Two perfect papers. I confused myself on that.
What about me?
Yes.
All right.
All I need is a 3. Can I have 3 more stamps? I want more stamps.
No. All right. So you shouldn't have a question, but you might have some questions. So what's that say right there? What does non-collinear mean? You gave me 3 points that make on. All right. It says what? This is the one I saw your diagram right here. So it's saying how far is it between not A and B, right? But between what?
A and C.
How far is it between A and C? Name the midpoint of AC. So AC goes from where to where?
There to there.
Okay, I'm gonna do it the easy way. Just kabonk, kabonk.
Yeah, I got that one right.
Coordinate of the midpoint of AC.
Whatever you want.
Did I take you 2 different tests?
No, the coordinate of the midpoint of AC is half.
3 minus 2 is 5. Half of 5 is 2.5. No, we gotta do this again. So from A to C, right? From A to C. That goes from -2 to +3. How far is it from -2 to +3? That's 5, right? What's half of 5 would be the middle?
Yeah, that would be 1.5.
2.5. No. 2.5 plus 2 is 0.5.
2.5 plus 2 is 2.
No, but you know what I meant. It's -2. Right. 2.5 bigger than this spot right here would be 0.5. So this is actually the middle. And the reason why you thought it was 1 is because, well, you thought it was going to be a whole number. All right, so that's that one.
Round it up, you would be right.
Yeah, that's true. And what does it mean to be adjacent? Just next to it. What's next to 1?
Oh,
2.
okay.
What's next to 3? 4. Okay. I don't even know what that is. What is that?
I think I was going for 3. Isn't that
Yeah,
yeah?
but you wrote the 3 backwards. Doesn't it look like an E to you? I don't know what it is either, but I know that 1 plus 2 makes what shape?
A line.
So I would have accepted 1 plus 2 is equal to, I don't know, somebody said is this straight line? Somebody put it was equal to 180, any of those would have been fine.
Okay.
And then this one, SOU, so give me SOU. How many degrees is SOU?
90.
No, look at it again, SOU, not SOV, SOU.
So that would be 1.
Just SOU.
That's 90 or 30.
Yeah, but it's not 90 plus 30. SOU goes, I'm just going to trace it out. SOU. So it's from here to here. How many degrees?
60.
It's 60. Right. So that was that. And then why is that one false? Two planes come together. What shape?
No,
It makes a line.
yeah, it makes a line.
Okay. We good, everybody?
Yep.
Okay. Today's a fun one. Review. I don't know if we'll get through this, but you will be responsible for the entire thing, and it's not that challenging today. Well, I'm just saying, I'm gonna show you the homework. If I don't get through the very last one, which I might not, we'll see. I might. We'll see. Okay. I'm not gonna go over homework. I'll just collect it. Here's your homework for tonight. You. All right. That sounds like a lot of homework. 1 through 27. Oh, it is. This is a lot of homework.
Oh, okay. But doesn't that mean it's easier, or at least mildly hard?
There will be some easy ones. There will be some challenging ones. If by some miraculous thing I actually finish the class on time, we can start working on it. I mean, I'm not saying this is 2 hours of homework. I'm not saying that, but it is 27 problems. All right, here we go. Special pairs of angles. Pairs meaning two. So these are going to be 2 angles, and together we give them one special name. All right, there's lots of these. Today you get 3. You get 3 of them. And oh, by the way, I've already taught you this in pre-algebra.
Oh, yeah.
You've already been exposed to this in pre-algebra. All right, here we go. Write this down in Book of Truth.
Oh.
The first pair of angles that get a special name are complementary angles. Remember when I did this in pre-algebra? I said, I don't know, I probably said, Anna, you look nice today. What am I giving her? Is that spelled the same way?
No, yeah.
When I say, Anna, you look nice, that's spelled with an I. Compliment. What's complement with an E mean?
It means they both go together.
They go together, like, I don't know, I'm not a fashion person, but her shoes match her eyes, or her face mask. I don't know, I'm reaching there for that, right? Allie's saying, well, that was not true. But you know what I mean, a complement is when we're saying 2 things go well together. That's with an E. And that's what we have here. So these are 2 angles that go well together because they add up to 90 degrees. Remember this pre-algebra? Yes, no? Okay. So here's your classical picture of 2 complementary angles. Okay, one's 30, one's 60, together they add up to 90. We haven't talked about right angles yet, but obviously that makes a right angle. Are these adjacent, McKinley?
Yes,
Why?
because they're exactly the same side.
No. The definition of adjacent angles means that they share both this angle and this angle, the 30 and 60, share a vertex, and they share a common side, right? So here's 2 angles that are not adjacent, right? If they share the same side, now they're adjacent to each other. They're like that, they're not adjacent either. If you can have these 2 angles like this, they still exist, but they're not adjacent. Those are adjacent.
Don't share a vertex.
Well, they could share a vertex, but not a common side.
So they can't share. So if
They have to do
don't
both.
share comments, it has to be both.
Has to be both for them to be adjacent. All right, this is the other example of complementary angles, two angles that add up. These are not adjacent angles, but they both add up to 90 degrees. We haven't talked about that thing yet, but we will. Next one, supplementary angles. Same thing, except each time they add up to 180 degrees. So how do you keep that straight in your mind? If you remember, I told you, see, complementary begins with a C, supplementary begins with an S. Complementary is 90, supplementary is 180. So it goes in order. Complementary, supplementary. The same two pictures, two adjacent angles that add up to 180, or two angles that are not adjacent, but they still add up to 180. We still call them supplementary. The one cool thing about these supplementary angles, McKinley, is what? They're adjacent, and what shape do they make when you put them together? A what? Yeah, you look at that. Now ignore this. What do they make? They make a line. If you have two angles that are supplementary and they are adjacent, they form a line. We're going to use that fact so many times this year. Right? Complementary, supplementary, complementary, supplementary. We good? Well, that's two. If we're only doing three, we're almost done, right? We're going to spend some time on the third one. All right. They are going to ask you some questions. The first one, this is a pre-algebra question. So what's, McKinley, the complement of 30? So what am I asking when I say what's the complement of 30?
The thing that makes it add up to 90.
So what's the complement of 30? What?
60.
What's the supplement of 30?
160.
That would be 190.
Oh wait, no, 150.
150. Okay. Remember what I said? Math and geometry is pretty rudimentary. Okay, so there's that. That's the complementary and the supplementary. So, but what if they don't tell you what the angle measurement is? They give you a variable.
Then you just multiply the
What's the complement of x?
190. Just
Girls?
89. Yeah.
Complement of x.
X.
Well, how did he figure out 60?
Just subtract. Oh, he just subtracted that from that. So it's 90 minus x.
So it's 90 minus x. Don't overthink this. What's the supplement of x?
180 minus x.
Okay. What's the complement of 3x?
The complement of 3x is 30 minus x.
Yeah.
No.
Why not?
Why would it be done differently?
Because there's a 3. So you don't
Doesn't matter.
Okay, so 90 minus 3x.
90 minus 3x. Now, we could factor out a 3 in that expression.
Yeah.
I'm not sure why we would do that, but
30 minus x.
yeah, but it would still be 3 times 30 minus x. You'd still 90 minus x, 3x, sorry. And the supplement of 3x.
180 minus
So
3x.
more likely, these last two are what you're going to see primarily in geometry. Okay, yeah, they may give you one or two of these. It's question number 1, question number 2. But most of the questions will, when they're asking you to make a complement, they'll make it hard for you and give you a variable. No big deal. We okay with complement and supplement? All right. So this is not big. I mean, it is big. I mean, it is really big. We will use this just like we use substitution. We will use this very frequently in proofs. So much so that it's one of the top 3. Substitution, this one I'm about to show you, and something called CPCTC, which chapter 2 from now. All right, it was a lot of letters, and you'll be thankful that there's a lot of letters. Okay, write this down. Hey, this is literally how Ms. Shankman taught me, my geometry teacher. What's the shape?
X.
She said, if you make two shapes,
I think
this
you're
was Shankman
underwater.
speaking from the grave or something. I don't know. So if you have two shapes that make an X, how many angles do we form?
4.
Okay. Now, it's actually more than 4, but everybody can see that there's at least 4, right?
Well, technically,
There's more, but we're not going to worry about the weird ones. It looks like there's at least 4 angles. I'm going to name them in no specific order. 1, 2, 3, 4. You see what I did? Okay. It turns out that there's a relation. 1 and 3,
and 2 and
3, 2 and 4. You guys remember that from 2 years ago? Turns out they are congruent, and we gave them names.
the exponent something in the it was the one with the
It's the worst name ever.
Top and bottom.
Ben, do you remember what these are called? The 2 red ones and the 2 blue ones?
Yes.
What are they called?
Aren't they called like opposites?
Yeah, wouldn't it make sense that these would be called opposite angles? Doesn't that make a perfect sense? The problem is we use the word opposite in math to denote 4, -4, -5, 5. So we can't call them opposite angles because then one would be 30 and the other would be -30. So even
What
though
about complements?
even though opposites would be the best name, we're going to call them, starts with a V,
Vertex.
we're going to call them vertical angles.
Vertical angle.
So this goes in your book of truth. And like I said, this is no joke. This is huge. We're going to use this probably every 2 or 3 proofs that we do, we'll use this. Vertical angles, especially when we get to triangles. You're going to see this all the time. Vertical angles are angles formed by the intersection of 2 somethings, 2 segments, 2 rays, 2 lines, also a combination, a ray and a line, a ray and a segment. The angles are opposite, so even though 1 and 3 certainly do look vertical, the 2 and 4 look horizontal from each other, but we still call them vertical angles.
Aliens attacks are like happen with math.
Yes.
Not in Mars Attack, they have fishbowls over their heads. There's a movie called Mars Attack, and the aliens attack and kill all the humans. And they have fishbowls over their head until they find out that they don't like yodeling. And then they yodel and their heads explode.
What?
What?
That's the weirdest thing I've
That
ever heard.
is
Sounds like something that McKinley would come up with.
It does. Okay, so vertical angles. 1, 2, 3, 4. What did you say, Jack, about vertical angles? What did you say you thought?
What do you mean?
You said that you thought the vertical angles are,
Jason.
no, you said you thought they were congruent.
Congruent, yeah.
Let's see if we can prove. There's a mistake on your page. It should say angle 1 and angle 3, not angle 2. Angle 1 and angle 3 are vertical.
So literally we just have to say the definition of vertical angles.
No, the definition doesn't say anything about them being congruent. It just says they're angles that are opposite each other when you make an X. So let's see if we can prove this. How do we start, McKinley? How about the given?
yeah.
All right, the reason is the given. And how do we end?
With proof.
Yeah, so angle 1 is congruent to angle 3. Hey, look at the board. See how far I got this down? It's going to take this much work to prove this.
So,
But it's not that hard.
so angle 1.
Okay, before we do that, I'm going to show you another technique.
You also have a problem there. Angle 1 and angle 2 are vertical angles. That's wrong.
That's wrong.
You didn't hear anything I said.
No, you put it giving.
Look at the bottom. Look at the statement.
No, the
It's not-
top one's wrong.
Oh, that one's wrong. Yeah.
Yeah.
No, the top one's wrong.
No, I said that I wanted you to change that to
Oh.
I didn't change. This should say 3. Okay. All right. Imagine these are not the droids you're looking for. That's a 3. Okay. So here's a technique, and I know I've talked to you about before. You guys know the puzzle maze, right? Start, finish, right? You got to go around. Sometimes you don't start from the start. You start from the.
Finish.
We're going to start from the finish. How do you show that 2 angles are congruent? Literally. As of right now, how can you show that 2 angles are congruent?
Angle 1 plus angle 3 equals.
No. How can you show that 2 angles are congruent?
Angle 1 equals 60, angle 3 equals 60.
So I need to literally show that they do what?
The same thing.
That they equal the same thing. So I need to, we're going to have other techniques later, like right after this. But one of the techniques is that we need to show that the measure of angle 1 equals the measure of angle 3. We have to show that. So I already know how this proof ends. It ends right here when I can show that the measure of angle 1 equals the measure of angle 3 by the definition of congruent. What does it mean to be congruent?
To be the same measurement.
Same measurement. So by the definition of congruency, that's how this ends. I already know how it ends. I just now need, I don't need to get to here. I just need, my puzzle maze. I went back a couple corners. Okay? So that's where I need to go now. I need to show that measure of angle 1 equals measure of angle 3. This is a hard proof until you see a trick that I'm going to show you. And the trick is this. You see the picture right here? The only thing that we get from this picture is that these two lines intersect and that this is angle 1 and angle 3. We get nothing. I can't even tell you that 3 is acute. I don't know if that's true or not. It could be.
Well, you do know,
It looks like it, but I can't prove it.
if you were to name the other angles, you do know that, for example.
So
3 plus
this
2
is the
1 plus 4.
technique called, there's not enough information there. We need to put some information in there. And by that I mean we're going to label.
So then you
Right.
just label 2 and 4.
So I could label this 2 and 4. I actually only need 1.
And, well,
And so I'm
yeah.
going to choose this one, not because it's special. I could have chose this one. I'm going to call this one, I'm going to say label angle 2. So you're able to label anything that you want. You can't say that, well, let's let angle 3 be acute,
So you
but I can say, hold on. But I can say, let's label that 2. So the reason for that is literally the word I can label, right? That's a common sense one. You can label anything. Notice this line doesn't have a name. I could label that AB if I put point A over here and B here. I don't need to do that for this one. Okay, so I just labeled 2.
So then
We okay? Okay, well, 1 second. We good?
Mhm.
Now you have a thought?
3 and 2 equals 1 and 2.
How do you know that?
Because they're a straight line. 1 plus 2 equals
Okay, so
180,
back up a
and
step.
3
What
plus
did you
2
just say?
1 plus 2 equals 180. and
Okay,
3
okay,
plus
hold
2
on that. So
equals
what he's
180.
saying is this. Take the magic hand. We cover that up. McKinley, what do we got?
1 and 2.
Which makes adjacent angles that form a.
Line.
So you could say it 2 ways. You can either say that 1 and 2 are supplementary, or you can say that they equal 180.
Yeah,
Let's see
and-
where we're going. Which
and
one do you
3
think I
and
want to
2
say?
And 3 and 2
Oh, and then we
equals
can do the same thing.
And then you could just say 2 equals 2.
Stop,
and subtract.
stop. You gotta wait.
Haley just emailed you.
Right? Okay. She said she wasn't going to be in class today, so I said that's okay. Lost my train of thought. Okay, so what were your 2 statements?
Which ones? I had like 4.
Oh, so did we were going to use that they're supplementary or they equal 180?
Equal 180.
Because I need to get an equal.
Right.
Saying they're supplementary isn't going to get me to that statement. But if I have an equal, then maybe that gets me somewhere. Okay, so tell me what you want me to write.
So then measure of angle 1 plus measure of angle 2 equals 180.
Semicolon.
The measure of angle 3 plus measure of angle 2 equals 180.
Okay.
Then you can.
Oh, wait. What's your reason?
Oh, reason is postulate 4.
That would be the angle addition postulate. That doesn't say they equal 180.
It does.
Doesn't say they equal 180.
Find supplementary
It
angles.
says that the big ones equal the other 2 added together. What makes it 180?
Supplementary angles.
Definition of supplementary angles. Notice I didn't put definition. I just said supplement. And by the way, a month from now we're just going to write sup. You might, and if you're really nice, you're going to put sup ANG.
So I should show that to my brother and be like, solve this, go.
Yeah, anyone in 3rd or 4th quarter geometry, you're going to put all sorts of abbreviations because you get tired of writing all this stuff. DEF-CONG, or maybe DEF and the congruency symbol. Okay, Anna, where are we going with that?
It's that-
Let Anna.
Subtraction.
What are we going to subtract?
The measure of angle 2.
Before we do that, what do we got to do first? She wants to do a subtraction. The only time you can do a subtraction is when you got the same thing on both sides. We don't have the same thing on both sides. On one side, we got 1, 2. The other side, we got 180. One side, we got 2, 3, 180. I like the subtract 2 part, but you got to do something before that.
Oh, you have to merge them together.
You see,
They
they
both equal 180.
both equal 180. So what can we say?
Well, you could say that measure of angle 1 plus measure
McKinley?
2 times measurement.
So what do you want me to write?
Measurement 1 and measurement 3 equal. Don't they? No, I got
You have the right thought, but you're not saying it correctly. If they both equal 180, set them equal to each other.
Yeah, just set them equal to each
So tell me what to write.
measurement 1 plus 2 equals measurement 2 plus 3.
Now you said it right. Is that what you're going to say?
Yeah.
Okay. Now what? Oh, but what's the reason?
Substitution.
Okay. Now what do you want to say?
Subtract.
What are we going to subtract from both sides?
Measure of angle.
Measure angle 2 equals. Now
You have a
some
reflexive.
yes, some strict geometry teachers at this point would require you to write the measure of angle 2 equals the measure of angle 2, that's reflexive, and then do subtraction. I just think that that's an obvious thing, right? So I am one of the I don't want to say the nicer geometry, I'm one of the less rigorous geometry teachers that when it's a truly obvious thing, I'm okay with this. And then you typically want to have the students just skip a lot of steps. The only step that I'm skipping here is a reflexive step because I just think that that's ridiculous. What do I need to say? It says measure of angle 2, it's an equation. I don't need to say that they're equal to each other. If this was 10 plus 1 equals 1 plus 10, I subtract 1 from both sides, 10 equals 10. Okay, oh, that was a lot of work. What did we just do?
Approved.
What did we prove?
That vertical angles are congruent.
So now we can say that. So, QED. Quad erit demonstrandum. So now we can actually say, this is theorem 2.3 in your book of truth. We can say that vertical angles are congruent. I chose these two angles, but remember, we're talking about any two vertical angles are congruent.
So now all I have to do is put this in, and that problem instantly.
And most people do never remember it's 2.3, so we're just going to say burnt ang congruency symbol.
What if I want to write the whole?
If you write 2.3 on your test, then you're going to force Mr. C to open up his book and to make sure that 2.3 is vertical angles are congruent, which I will do happily, but I'm never good. You won't either because the time you're not going to want to flip back through and, oh wait, is it 2.4 or 2.2?
So is that like the vertical angle theorem?
We just say vertical angle theorem.
Can
Right.
we just write the?
Or you
2-3?
just simply write vertical angles are congruent.
What about just the 2-3? Would that work?
Well, like I said, you're gonna have to remember that, or you're gonna have to look it up. Or if you do all that, I will look it up. I'm not gonna take off points for it. I'm just saying I've never had a student do that. They'll just say vertical angles are congruent or vertical angle theorem. You know, one of those. We actually get two statements from this. What two statements?
Well, we could use a what's it called?
Oh my! I said so much.
Well, what's the obvious one we get from this?
Measurement of angle 1 equals measurement.
That's the obvious one, right? So if 1 and 3 are vertical, then we get that. What's the unobvious statement?
Measure of angle equals measure.
Okay, we get both of those. So if you use either one of these statements as one of your statements in a proof, your reason is the theorem 2.3, the vertical angle theorem. Or vertical angles are congruent. Well, that didn't seem so bad. That was 3 of them, right? We did supplementary, we did complementary, we did vertical angles. So there's your angle pairs that are called special pairs of angles. Now it is geometry, so we will make it slightly more challenging. You ready for the slightly more challenging?
Yep.
Okay, so you gotta be careful on this.
Oh.
Right, you ready?
I see
Oh
it.
no.
All right,
B.
is this one complicated?
Not really.
No.
So what is vertical to 4?
Now you have to just draw a line through it.
What is vertical to 4?
2.
Okay, that's easy, right? They're not gonna give you this, they're gonna give you that. So what I recommend lightly with your pencil, well, what's vertical to 2?
6.
That one's easy. So what I would like for you to do is do this so that you can visually see
So then,
that 2 is to 6.
so then both 4 and 5 are equal to 1.
But wait a minute, this is hard.
No,
What is 1 to?
4 and 5
See?
combined.
Combined. So 1 is equal to 4 plus 5.
Or 2 times 4, or 2 times 5,
One more time.
or 2 times measure of angle 5, or 2 times measure of angle 4.
Only if L, whatever that is, KL, I can't read it,
Is a bisector.
is a bisector. But that would be true. If it's not a bisector, it's not labeled as a bisector, you can't say that.
So then you just have to label. So then you just have to label.
What you said first was the easier, just 1 is equal to 4 plus 5. Right? But this picture right here they use a lot, right? Notice one of them, it doesn't even go all the way through, and then they ask you to pick out the vertical angles, and it's just a mess. So just be really careful. It looks like 7 goes to 3, but you better be careful, right? Okay, so they're going to give you something ugly like that. I'll show you what it will look like. It'll look like that. It's on your paper. So we'll start with Anna. 5 is vertical to 2. Then 1 is vertical to
It's vertical to 4.
Correct? And McKinley, 6 is vertical to
3.
All right, so that isn't too bad. Just be ready. There's a couple diagrams that are really ugly tonight for homework.
Well, what if you don't want them to be ugly? Can I make it simplify them? So
They're going to make it slightly more challenging by giving you this. Okay?
Well, don't you just have to
What's it
start
say?
measurement 1 equals 30?
Lightly in your book, on your paper, find 1 and label it 30. You see that?
Okay.
You said that 1 is vertical to what?
No, 4.
So therefore 4 is 30.
But it's not 30 degrees. It doesn't say 30 degrees.
Yeah.
Okay, so this is a book formatting thing. Our book, when they see measure angle, they don't put a degree symbol.
Oh, okay.
Okay? But if I'm just labeling, I'm going to put a degree symbol.
Does it because it could be like cubic feet, not right?
You're
So it could be-
exactly right.
So
It says 6 is 110. So what's vertical to 6?
3.
Okay, so 3 is 110. Let me catch up.
Well, that means the other.
Holy cow, how are we going to figure out 2?
Well, it's the exact same as 1.
How do you know?
We
Because
never
it
see
is
it to bisect.
Doesn't say it's a bisector.
But it's right next to each other. So it is
Doesn't mean.
Well, all of them equal 360.
Yeah.
Okay, but we're missing 2.
Right. So then add them together and see what you have left for 360 and divide it by 2.
We could do that. There's another way of doing it. That's fine. You see what he's saying? 360, right? We're only missing 2, and they're vertical to each other.
Yeah.
So-
we just
Add, subtract from 360 divided by 2. There's another easier way of doing that.
Common sense.
Go back to what I did with McKinley from the very start.
or you could just take it from half from that first line.
You see this?
It's a line.
How many degrees?
180. So
1,
then-
2, we're only missing 1.
Right. So, yeah. Okay. That's
I'm
what-
not saying that my
that's what
way
I was
is.
about to say, but
I'm not saying that my way is easier than what you said. You're saying your way was perfect. Just be careful. The only reason we can use it is because 2 and 5 are vertical. If 5 was not there and it wasn't vertical to 2, then we have to use this way.
right. Yeah.
Okay? Oh, by the way, what's the answer?
40.
What is it?
40. Yeah.
40.
80. I got 40.
40.
It's 40.
40.
It's 40. Okay. So 40. 180 minus 40. 140 is 40. Okay, very good. Last one right before the bell. No, you don't need a break. It gets slightly more complicated with this one. This one isn't too bad.
Oh, okay. So then 2x plus 5 equals 65.
I can ask this 2 different ways. How did I ask it?
You did. You just.
How did I ask the question?
Oh, just by diagram.
Yeah, but how did I ask the question?
Times by x.
The other way it could be asked is, how big is that angle? Well, it's kind of easy for this one because this one already tells us, and they're vertical. So how big is the angle?
65.
But generally, they won't tell you it's 65. Maybe they'll say something like, I don't know, it's equal to 10x plus 4.
So then you just
And then
gotta.
10x plus 4 equals 2x plus 5.
And solve that for x, and then throw your answer. I made that up. It's not going to come out nice. Throw that back into your equation to find out what each is. Expect both of those tonight for homework. Oh, by the way, what's the answer here?
30.
Cool? Okay, pretty simple day.
Those are my
All right, right on time. All right, you see the diagram?
Oh, that's not so hard.
That one's not too bad.
Wait, we're doing classroom exercises?
No, I'm just pointing out that, homework. This isn't homework, this is classwork, but, I mean, the diagram won't be the pre-algebra, there's just an X.
Will that be like a homework?
Yeah, there's a couple of them like that. Ugly. Look at this sucker.
Oh, okay.
So this is a
Okay.
3-dimensional. This is a pyramid
It's
right
just a
here.
three-dimensional
Yeah,
x.
it's a three-dimensional X. Yeah.
So you really have to strain your brain to try to
That makes
figure
sense.
this out. So
It looks intimidating, but
it's saying that VTR is a right angle. So VTR. So this is 90 right here.
no. Oh yeah.
It's saying QSR. QSR is 60. So from here to here is 60.
No. QSR, not RSP.
I got it right.
No.
All right.
QSR, not RSP.
I got QSR.
No, wait, what?
QSR.
Oh, right, because of rotation. Oh, I was looking at QRS.
So that was pretty ugly. We don't need to do that one, but got it?
Yep.
Bell rings in like right now, right?
Yeah, it's a little off. It's a little off.
We have like
How much?
2 minutes.
2 minutes. Okay. You want to try this? Let's see. So
Uh,
we got 2 minutes. So let's see. VTR is a right angle. This is 60. So how big is QRS?
if it's 90,
That's not even a question, but how big is QRS?
I don't. How are you supposed to tell that?
No, you know this one's 90.
Right,
You know this is 60.
right. But what? Oh, so it has to be no. Oh, it's 30
Where are you getting that from?
because no, yeah, because anything on the inside of it is 180. So 90 plus 60.
Yeah, but which triangle are you looking at?
I don't know.
This one's right. That one's
Is?
30.
What? Oh, what?
Now, be
Oh,
careful.
yeah.
I'm not pointing to VR. I'm talking about the triangle that's on the bottom because we already know that's 60. So this one, QRS, is 90. It's not one of the, it's not asking us that. Does it ask us what SQR is?
No.
Nope, that didn't get us. We need to find VTP. VTP, well, that's also 90. Okay, that one's done. Equals 90.
Well, we don't know that, do we?
We do, because the one opposite is 90,
Oh, yeah, you're right.
right? And so two that make 180 degrees, so 90. Okay. B says XSY. XSY. You see the X?
It's 60.
Yeah, because it's vertical, so that one's 60.
Even though it looks.
Well, if not, then you just draw the line. So that goes there. That oh yeah, they're vertical. Okay, RSX. So that's 60. This is 60. That would leave.
That would leave 90 and 90. Right?
No, they make a straight line. RSX.
30.
30.
No.
100. No.
Who said 120? Right, Anna? Why 120?
Because it's 60 plus 120 equals 180.
Okay, it's because they make a straight line, right? 100, 120, and then last one PSY. PSY, where's PSY? PSY. Oh, so this one right here. This is 120.
So that's one.
That's 120. There you go. Half the problems with geometry is that right there. Just understanding the picture, right? All right, Ben, see you tomorrow. Remember, I'm going to post the quiz. I don't care if you take it tonight or tomorrow, anytime at your leisure. Just make sure it's done at least 24 hours from now, yes?
Okay.
Later.
24 hours.
Bye.
41 tomorrow. Exactly.